Let's solve question number 4, guys. So what we have here, the process that is not endothermic in nature is Ar accepting an electron giving you Ar minus ion, hydrogen accepting an electron giving you hydride ion, sodium losing an electron giving you Na plus ion, O minus ion accepting an electron giving you O2 minus ion. So if you look at the first reaction or the first process, it's talking about electron gain enthalpy. The second is also talking about electron gain enthalpy, right? The third one is ionization enthalpy. Fourth one is the second electron gain enthalpy, guys. Fourth one is the second electron gain enthalpy. So if I'm looking at the first one, Ar is an inert gas. Ar is an inert gas. And if you're giving an electron to an inert gas, that process will be what? That process will be endothermic. So here the value of this will be positive. Second one, the electron gain enthalpy of hydrogen. Electron gain enthalpy of hydrogen is what? Is negative, guys. Okay. Sodium losing an electron. If sodium loses an electron, then it will be what? It will be positive because ionization enthalpy is positive. O2 minus is formed, right? O minus accepting an electron and forming O2 minus. Second electron gain enthalpy is positive. So the answer is option 2, guys. Okay, because this process is exothermic. Rest all are endothermic. Let us solve question number 5. The one that can exhibit highest paramagnetic behavior amongst the following. Okay, GLY stands for glycinato, BPY stands for 2,2-bipyridine. Okay, so in the first option what we have all the three strong ligands. All the three are what? All the three are strong ligands, and Fe is having an oxidation state of +2, right? So it will be 3d6. So the number of unpaired electrons in this case will be what? The number of unpaired electrons in this case will be 0 because all the electrons will pair up. All the electrons will pair up. In the second case, if I'm talking about PD, so PD will have oxidation state of +2 because GLY has an oxidation state of -1. So here this will be 48 and the hybridization over here will be dsp2. So all the electrons are paired. Again I will have 0 electrons over here. In the third case, what we have is oxalate has an oxidation state of -2. So oxidation number of cobalt will be how much? So oxalato OH, right? This is -2 multiplied by 2 and this is -2. The overall is how much? The overall is -1. So X plus this is equal to -1. So the oxidation state of cobalt, is +5. Oxidation state of cobalt is what? Is +5. So if I'm looking at the oxidation state of cobalt as +5, so how many electrons I am expecting over here? So this will have how many unpaired electrons? This will have 2 unpaired electrons. This will have how many unpaired electrons? This will have 2 unpaired electrons. In the last case, titanium in the oxidation state of +3. So titanium in the oxidation state of +3 will have how many electrons? It will have 1 unpaired electron. Right? So maximum number of unpaired electrons are with cobalt, right? So cobalt will exhibit maximum paramagnetic behavior. So your answer is option 3. Let us move on to the next question, guys. The crystal field stabilization energy of COF3 H2O thrice del naught is less than pairing energy is -0.8 del naught, -0.8 del naught plus 2p, -0.4 del naught, -0.4 del naught plus p. So here what we'll do is we'll simply calculate the oxidation state, number of unpaired electrons, and we'll calculate the crystal field stabilization energy. So what is the oxidation state of cobalt? Oxidation state of cobalt is +3. So in the +3 state, it will be what? +3 state, it will be 3d6. Fluorine and H2O are weak ligands. So because fluorine and H2O are weak ligands, so what will happen? For pairing, I require more amount of energy, and for promoting the electrons, I require less amount of energy. That's why what we'll have is, this will be written as T2G will have 4 electrons and EG will have what? EG will have 2 electrons. So here these electrons in T2G will be 1, 2, 3 and 4. Here in EG you will have 2 unpaired electrons, 1 and 2. So we have 4 electrons in T2G and we have 2 electrons in EG. So we'll multiply these 4 electrons by what? We'll multiply these 4 electrons by -0.4, and these 2 electrons will be multiplied by what? Will be multiplied by 0.6. So this will be -1.6 plus 1.2. So this is -0.4. So this we have calculated crystal field stabilization energy is -0.4. So the answer over here is what? Is option 3, guys. Okay. So I hope you have understood this. A very simple calculation of crystal field stabilization energy. In the following reaction sequence, C is. So we have to predict what is C. So let us look at each and every step. Before we look at the options, I suggest that you solve this and then you go at the options. So what you are doing, you have NH2 and CH3 attached to benzene. So which molecule is this? This is paramethyl okay. So we are carrying diazotization of this, followed by CuCl2, Cu2Cl2 plus HCl. So what reaction is this? This is Sandmeyer's reaction, guys. What reaction is this? This is Sandmeyer's reaction. So we are going to convert NH2 to what? We are going to convert NH2 to Cl, right? So what do we get? Cl, CH3. So what will be B? B will be right. So this is your B, guys. We have a Cl which is attached to CH2, right? And after this, what you're doing, you're carrying out Wood's reaction. You're carrying out what? You're carrying out Wood's reaction. So if you're carrying out Wood's reaction of this compound, what will I get? Let's see. So what compound we have? We have Cl, and I carry out a Wood's reaction of this. So if I carry out Wood's reaction in presence of sodium and dry ether, so this will give me Cl, CH2, CH2, Cl. So that's your final product, guys. That's your final product that you're going to get. Now let us match it with the options that are available to us. Okay. So what do you think is the answer, guys? We have seen what is A, what is B, and what is C. So what is our C? This is our compound C, right? So the final answer is option 2, guys. Okay. Is this clear to all? Anything that is not understood, just remember Sandmeyer's reaction and Wood's reaction. So from this compound to A, it is Sandmeyer's reaction. Then second step is chlorination, and third step is Wood's reaction. So your final answer is this guys. Okay, let us move on to the next question.